Assalamu alaikum. Today we will continue our course, Instrumentation and Process Control. We will start the second part of the course. And last week we finished the Process Control 1, or the first part. I already divided the first part into 4 chapters, and I will upload it inshallah in the Google Class soon. Today we will start the second part. The second part consists of 2 chapters. Process Control 5, we will start today, and Process Control 6. Process Control 5 title is Variable Measurement. What's the variable measurement? What's the variable? The variables, as we explained before, is temperature, pressure, flow, whatever. The variable is the one we need to measure, the one needs to be controlled. We will study type of variables and the mechanism of measurement. But before that, we will have a quick review in the control system elements. Suppose this is a process. Just a second, the laser point. Suppose this is a process, and this three is the 3 element of control: the sensor, controller, and final element. The sensor senses the variable. Transfer, it has a reducer in it, transducers. It changed the signal, create a signal, electrical or whatever, or send it to the controller. The controller receives the signal, process it, compare it to the desired value, measure the error, and generate another signal according to the software, according to the program, generate another signal and send it to final element. Final element receive the signal and change it into action. For example, open the valve, open control valve or close control valve, start pump. Temperature measurement, thermocouples. The thermocouples temperature measurement is the one we see here. It consists of 2 dissimilar wires, A and B. A and B, when we heat these 2 dissimilar wires, they generate an electromagnetic force, voltage, in millivolt, of course. This millivolt then goes to the measuring device, and according to the value of this voltage, it shows the pressure. The more value, the more heat, the more value, the more the gauge show. And this one is the thermowell, the device that should be inserted in the place in which you need to measure the temperature. And thermowell inserted inside, thermocouple inserted inside the thermowell. These 2 dissimilar wires, for example, they are different types. For example, E, G, K, L, and every model depends on what type of wires we have. Those wires could be 1 metal, pure metal, or could be a composition of 2 metal or 3 metals. For example, part A, if we talk about model E, it's wire A is a chromil and wire B is constant. Chromil from chrome, يعني معدن الكروم. And this choosing the model depends on the temperature range. طبعا هذا it's regarding of designing the device. We will not go deeper in it. It will take long time. So for your information, you need to know that the thermocouple consists of 2 dissimilar wires, يعني مختلفين في مقاومة 8. When we heat them, they generate a voltage, and this voltage transmitted into temperature. Okay. Temperature measurement, thermocouple response depends on the thermowell location. Of course, that thermowell should be located exactly in the place you need to measure the temperature. Usually, instrument has an error. Of course, it's not exact 100%. This should be an error. there may be additional offset in the thermal. If the thermal is incorrectly located, it will not sense the right temperature. This should be an sometime offset. It will not the voltage will not be generated. Response is fast. طبعا الريسبونس والvoltage generation is fast when the thermal is installed in the flow stream في المكان اللي فيه flow. طبعا الريسبونس or voltage generation will be fast. Sometimes thermocouples are also strapped at the wall of the tank. Of course, it installed mostly if we want to measure a temperature of storage tank, the thermal should be installed right in the place. For example, if it is crude oil, it should be installed right below the level, or the set point of the level. Temperature control, heat exchangers. For example, suppose this is a heat exchanger. How we can control the temperature? This is the process stream, and this is the place that needs to be, the temperature needs to be measured. The outlet of the process stream. And this one is bypass line of the heating element, or heating or cooling element. Of course, heat exchanger means there is two subjects. One process stream, and the other one is sometimes you call it heating element or cooling element, whatever. The one who transfer the heat or opposite to the process stream. Temperature control for an heat exchanger is usually by manipulating the flow through a bypass line. We can manipulate the flow by this bypass line. For example, if the temperature here goes above the set point, so this control valve should be open more in order to allow fluid going by the bypass, not inside the tube or inside the shell, to avoid any heat transfer more, because the temperature goes above the set point. And opposite, if the temperature goes below, this control valve should be closed in order to allow more heat exchange. Temperature control, for example, air cooler. There is an air cooler. This is the air cooler. You know what's the air cooler? الاير كولر هو طبعا هو مبرد بالهواء، يعني يعتمد على مروحه ويخلي حركة الهواء ما بين التيوبس. في تيوبس هنا في bundle of tubes, and this is fans، مراوح بتشتغل بالموتور كهربائيا تعمل flow through the tubing, and of course it reduces the temperature of the process flow inside the tube. We can control this device by two types. For example, control the rotation of the impellers, or control the flow inside the tubes. يعني we can control the rotation of the impellers. يعني ممكن تحكم بريشة المروحة، ممكن يزيد ال RPM ولا ينقص ال RPM. RPM is rotation per minute. For example, if the temperature here goes increased above the set point, we have to increase the rotation of the motor. يعني it gives a signal to the motor to run to increase the RPM in order to cool down in order to reduce this temperature. And contrawise, if the temperature here goes below the set point, this motor will be stopped or will be speed will be reduced. Okay, if the motor and impeller goes with fixed speed، يعني السبيد not change، ما بتغير شيء ولا بتحرك، then we can control the flow by bypass line. If the temperature here goes up above the set point, we can open this control valve to allow more liquid or more process flow goes, bypass the heat exchanger or the condenser or the cooler and counterwise. Ambient air temperature is varies. طبعا of course the ambient temperature plays a big role here. يعني الambient temperature لو لازم تكون ناقصة enough، يعني بكفاية ان تبرد. يعني for example انت شيء تبرد هذا إلى تبرد الفلو هذا إلى مثلا درجة حرارة 20 ولا 25 درجة مئوية وأنت ساكن في عدن ولا في حديدة الدنيا حمام، مستحيل إن الهواء يبرد هذا الشيء. I think it's clear. Temperature control signal, for example, this heat exchanger. Same. This is a hot or cold utility. This is the process flow that need to be controlled. The temperature here needs to be controlled. It's the same. Temperature valve, same like that. يعني هنا depends if we want to heat or want to cool down. Okay, now we will start a pressure measurement. Pressure instrument usually measure differential pressure. When we need to measure the pressure, we should have 2 points. One is a reference point and the other one is a point that needs to be measured. For example, if the one side is atmospheric, then the difference in the difference is the process gauge pressure. يعني لو one side is atmospheric pressure يعني معلوم يعني known pressure, then the difference between them is the gauge pressure, and usually it's written as a bar G or psi G. يعني one is known, for example atmospheric, and the other one is the gauge pressure. Of course not absolute. The absolute pressure is the total, assume يعني هذا plus هذا, يعني gauge pressure plus atmospheric pressure is absolute pressure, we can say that. How we measure the pressure? There is different type of measuring the pressure. Mechanically we can measure the pressure by displacement of diaphragm or Bourdon tube or anything. يعني displacement الجنريشن الpressure create a displacement of device of diaphragm or Bourdon tube, and this displacement lead to change in gauge or pointer. يعني pointer like الجيج يعني البوينتر المؤشر في الجيج هذا بس يعني يعني indicates the location of the pressure يعني in the number أو how much the pressure. The second type is electrical. في electrical device to measure the pressure by measuring the resistance. يعني just the pressure transmitted into electrical signal, and according to this signal there is an electrical gauge showing the pressure. وفي third type is capacitance يعني عبر diaphragm moves عبر مقاومات يعني diaphragms يعني في diaphragms when it moves on the capacitor place is generate a signal to indicate the pressure how much. And the other type is piezoelectric. هذا خاص بأشباه الموصلات or measure the conductivity between semiconductors. يعني بنحط semiconductors in the device where to measure the pressure, and according to the conductivity يعني البريشر مثلا when the pressure goes up, this semiconductor create the conductivity is more. And of course there is an electrical board that can transmit the conductivity into numbers يعني pressure. For example, the first pressure gauge is the liquid column. طبعا كلنا نسمع على عمود الماء، في عمود زئبق في عمود ماء. liquid column looks like this. عفوا مش pointer. Looks like this. As we see, there is a liquid in it, mostly maء. Different level, and there is a delta or H. Delta H is the difference between the height here and the height here. Of course, one side of this tube is known, or for example atmospheric pressure يعني مفتوح كل الاتموسفير أو شيء. A different point we need to measure. By this formula we can measure the dB. mg delta H. طبعا m is the quantity of the liquid in the tube, g is the density of the liquid, and delta H is the difference in height. The second type is Bourdon gauge is mechanical. This gauge is this is the Bourdon tube. We call it Bourdon tube. It moves. It has an ability to expand when the pressure goes up here. يعني مع الضغط بيحصل له expansion. When expanded, see this thread المؤشر إيش يتحرك, moves, whether up or down, and indicate the pressure. How much? This we call it Bourdon tube. It's a mechanical type. And this is the pressure from the source. When we apply pressure here, the Bourdon tube expand and the pointer moves. Diaphragm, برضو mechanical. Here, the diaphragm moves. When we apply pressure, these diaphragms expand move this arm. وبعدين هذا برضو مربوطة بمؤشر. يعني it's linked to the pointer and show the pressure. This is electrical. This is the most used in the process industry. هذا electrical. It's showing the pressure. We apply the pressure here and measuring the semiconductor conductivity. It's يعني according to the some transistor inside and showing the pressure here. And this wires is to transmit this value into another program, for example PLC. Pressure control. Let's say how we control the pressure. For example, we have this vessel. We need to control the pressure in it. Of course, the element of control is PT, pressure transmitter, pressure indicator controller, and pressure valve or pressure control valve. Here we apply set point. We set certain pressure. And when the pressure transmitter sends the pressure, transmitted the signal to the controller of course generate another signal and send it to control. When the pressure goes up, this control valve opens. When the pressure goes down, this control valve closes. Pressure control usually by venting a gas or vapor. A hydrocarbon process of gas often vented or fueled. Here is vented, and mostly it should not vented like that. It should connected to the relief system, for example water knockout or knockout drum or flare or whatever. Pressure control, for example, another example, we have a vessel. The pressure the control needs to be the pressure needs to be controlled is here. Pressure transmitter or same linked to the pressure indicator controller, and the pressure indicator controller gives signal to the control valve according to the here we have a condenser, the vapor. If the vapor has a high loading of condensable material, then the pressure control is on the vent of gas stream from the condenser. We have here a condenser. هنا بيحصل condense للvapors. If we this the vessel, we have a vapor in it, and when the vapor the quantity of vapor goes up, the pressure goes up also. So when we condense يعني عندما نكثف, the pressure goes down. The pressure goes down. That's why we need to control the pressure, the vapor coming out of the condenser. يعني كل ما إذا زاد البريشر احنا ممكن نفتح هنا أو نزيد من الفيبر اللي جاي هنا، أو نزيد كمية الكندنس بعدها يقل البريشر، والعكس صحيح. Pressure control condensers. Alternatively, for condensers, we can control the coolant supply or the heat transfer service. For example, see this example. This is a heat exchanger. We add coolant. We need to cool the process stream. This is the process stream. We need to cool it. So we have a coolant element. a coolant element. For example, through the tubing and in the shell, the process stream. We need to control the pressure here. How we can control the pressure? By controlling the quantity of coolant. يعني, for example, if the pressure goes up, we have to increase the coolant in order to cool more, to reduce the temperature and sequentially reduce the pressure. Here, in the second example, process vapors goes into the shell, and in the tubing the coolant. If we need to control the pressure here, by controlling the quantity of the vapor coming out. If the pressure goes up, we have to open this. Open a little bit so the pressure will drop down. This is